Today I'm going to talk about Intelligent Resilient Framework, IRF. IRF is an HP technology that allows you to stack multiple switches into one logical switch. So I have I actually have a topology here that I'm going to use to show you how you can configure it. So let's talk about the master or the master slave election. Um, this is this is just some notes that I have here. So the switch that's the master stays the current master. Uh, if the master goes down, one of the slaves becomes the master. If the master switch comes back, again, it will come back as a slave because the current master stays the current master. If you don't have a current master, it's done on priorities. So 32 being the highest priority. Uh, if you want to force a switch to become a master, and default priority is 1. So let me actually go here, uh, enter. This is so I have two switches connected that has connections to each other, and this is the ports on the ports on switch 1 and ports on switch 2. So let me actually do because this is a new switch. I haven't configured this yet, so I just want to show you that the default priority is 1 here, as it says here. So I'm gonna do display IRF. So priority is 1, and member ID also is 1. That's the default also. So in IRF we have a master or slave. So I just read the master slave election some rules here. So the current master stays, I mean the switch that's the master stays the current master. I'm reading this again. If the master goes down, one of the slaves becomes the master, the one that has a higher priority. If the master switch comes back again, it will come back as a slave because there is already a master, a current master. And if you don't have a current master, it's done on priorities. So you can actually, like it says here, you can actually force a switch to become a master by setting its priority to a value of 32 because that's the highest value. So I have a step or IRF configuration steps here, short and easy. So it has 1, 2, 3, 4, 5. So this is a real world step-by-step procedure because if you're gonna do this in, let's say, this HCL software, you have, you have uh, console connections to both switches, uh, which is not usually the real scenario, um, typically, right? In if you are working for a company, you usually you only have one console connection to one of the switches. So that's why this is the steps that I created. So Let me actually go here, go to our topology. I'm going to start with switch 2 because this is, this is, we are just trying to simulate that we only have one console to one of the switches. So I'm going to start with uh, switch 2. So connect the switches using two. This is something that should be performed by someone on site. So connect the switches using two 10 gigabit ports and power them up. The ports that we are going to use in this lab is this port, 10 gigabit Ethernet 1051 through 1052. And let me just try to do this. So this is something that you ask to the, like I said, to someone on site to connect the switches uh, using the designated uh, cables. So in this case, these cables, and power them up. So ask them to power them up. And second step is console into switch to and issue the following commands to verify port and IRF status. So I'm gonna actually do this. Display interface brief. So this is just to check that the the ports. I mean to check the ports. So in this case, this switch has uh, 48 gigabit ports and 10. I mean four 10 gigabit ports, and this is just a lab. So this is actually a S5820 series switch. Let me actually do this command device. So this is the device name. So S5820. And I showed you this command earlier. I mean display IRF. So the default member ID is one. Uh, the default priority is master, and default priority is one. Did I say priority? Member ID is one, and this is the CPU MAC address. So step three, this is actually step three. So renumber switch to ports, save configs, and reboot it. So you go into system view, sysname. I'm gonna just copy and paste this. So I'm just copying and pasting the commands here. So yes, continue, and save force, and exit or quit, reboot. Yes. So system is rebooting now. So this is, I can actually go ahead and configure switch one and this. I mean, because we are just using a the software here, HCL, but we are simulating that, like I said earlier, we only have one console connection to one of the switches. So switch has rebooted. So I'm gonna do display I interface brief, and as you can see, the ports um, earlier it was gig one 0, 1 through 48. Now it's actually gigabit Ethernet 0, I mean 20, 0 through 48. So the switch member ID or switch ID has changed from 1 to 2. Let me do a show display IRF. So member ID is 1. The rest is the same. So we just remember the member or the switch ID. So IRF domain. So in this case, I'm specifying the IRF domain. Default is 0. So here, domain ID is 0. So I'm gonna go ahead and just copy and paste these commands. So IRF MAC address persistent timer. This is the MAC address that is used by layer 2 protocols. For example, LSCP. So I got this from one of the documents from HP. I'm gonna add it to the link to the description of this video, so you don't have to look for it. So this is just a MAC address that, I mean, this bridge MAC address is used by layer 2 protocols, for example, LACP, to identify the IRF fabric and must be unique on a switched LAN for proper communication. I believe by default is 6 minutes before the master uh, release its MAC address. So the MAC address that's being used here is the MAC address of the master. So it's just saying uh, that the master won't release uh, the the MAC address until the timer expires. So I believe the timer is 6 minutes by default. Next is I'm gonna copy and paste this command. And by the way, also this is actually enabled by default. So let me do this command IRF. So it is already configured by default, and as well as this command also, this command. But I'm just gonna copy and paste it. And this one is also enabled, configured by default, as you can see here, and undo IRF link delay. This is just to delay the reporting of the port that has gone down. But in this case, we are not using that timer. We are disabling that feature. So IRF member 2, priority 20. So in this case, we are specifying the priority to 20. And this we are just specifying the description. So here, let me go back to the topology. So we are using these ports, 51 and 52. So I'm using the range feature. So I'm gonna shut down the ports before I add them or bind them to the IRF ports. So this is the IRF port. And this is how you add logical IRF port. And this is how you add the physical port to the IRF port. So it says you need to execute this command to activate the IRF ports. So another logical IRF port, because we are adding two physical ports. And you need to unshut the physical ports. Quit. unshut. Interface range 10 to 10 to 0 52. Undo shut them. And this is how you activate the IRF ports or IRF configuration. And save the config. You can use exit or quit. So save force. And I'm gonna do display IRF just to make sure that the priority ID has changed. Role is still master. Uh, member ID 2, and this is the description. So let me go to, so switch to is finished. Um, let me go to switch 1. So line aux0 is available, meaning that we are connected to the switch via console connection. So system view, I'm just gonna copy and paste these commands. So this is the same IRF domain that we configured on switch 2, and this is enabled by default, but I'm just copying and pasting them for the completion sake and completion. IRF member priority 30. So on switch 1 it's priority 20, and on switch 1, I mean switch 2, we configured priority 20, and but on switch 1, on this switch, we are configuring priority 30. So this is gonna be the master, and switch 2 is slave. So this is just to specify the description. So quit. So you have to, again, like what we did on switch 2, we have to shut down the, you don't have to quit. You have to shut down the physical ports before you add them, you bind them to the IRF ports. So port group interface and the name of the interface. That's the command to bind the ports into the IRF ports. And you have to also uh, issue this command to activate the IRF ports. I'm gonna do that. So it says here that this will cause switch to reboot as it will be added to the stack. So as soon as I enter undo shut here, uh, switch to, let me go to switch to. So as soon as I hit enter here, switch to should reboot. And I think it's rebooting now. Let's just give it a few seconds. Yeah, it's rebooting. So it's just doing its thing to bind the the switches into one logical switch. So press enter to get started. So when I hit enter, it says switch 1, switch 2 is gone. So let me do a display IRF. So a member, plus meaning that this is the device that we are on. So this symbol here. So this is the standby. Standby. It's actually standby, not slave. But in the documentation, I believe it was slave. But same, it's just the term, same concept. So master is switch 1, which has the member ID 1. So that is the priority 30. So in this case, switch 2 has a priority of 20. And we can actually do this commands to verify the ports. So before, we only have 48 ports. Now uh, we have these ports and we have these ports. So this is the ports on the master switch, and this is the ones on the standby switch or slave switch. Let me go to the topology and do let me save the config, do a display IRF as well. So that plus sign, so meaning that we are logged in on this device. Display IRF configuration. So that's where this is where we can see the physical ports. Display, what else? Topology, IRF topology. So neighbor, we can see the neighbor link, and so as you can see, the IRF fabric is using this MAC address, the MAC address of the master switch. So same MAC address. So yeah, that's how you can configure IRF on HP switches. So thanks for watching.